Hey everyone, welcome back to Advent of Cyber 2 by TryHackMe. I'm Dark, and today we're going to be doing Day 2, The Elf Strikes Back. Now, if you missed Day 1 and John's video on that, I will have it linked in the video description, and I do recommend checking that out. Don't forget, you can still join in the event, and you can still do all of the tasks. The room is going to be up permanently, however, you can do tasks to be included in the raffle for prizes up until the end of the competition, so you still have tons of time. And I do recommend checking out John's video on Day 1. That man has way more pep than I ever could have in a video, and it's he does a great job with Day 1. Definitely recommend checking that out. That being said, let's go ahead and dive into Day 2, The Elf Strikes Back. After your heroic deeds regaining control of the control center yesterday, Elf McSkitty has decided to give you an important job to do. We know we've been hacked, so we need to find a way to protect ourselves. And this is actually typically what happens after an attack is your IT team steps up, or whatever IT team for a company will step up and improve security after something happens. The dev team have set up a website for the elves to upload pictures of any suspicious people hanging around the factory. But we need to make sure it's secure before we add it to the public network. Please perform a security audit on the new server and make sure it's unhackable. You listen to the briefing and accept the task, pressing the deploy button to start the server as you do. McSkitty once again gives you a dossier of useful information to help you with your task, which you read as you wait for the server to boot. In this case, I've gone ahead and deployed the box attached to this day already, as we can see over here, and we'll dive into it once we are done reading through this. If you're following along with me, I recommend clicking deploy now because this will take a little bit to come up. Dossier completed by Maryland Oracle. He is the lead mod on the Discord, and he did a wonderful job with yesterday's task as well as today's task. Get parameters in URLs. We looked briefly at the differences between GET and POST requests in the previous dossier. However, the emphasis was on the POST request used in a login form. The server you'll be testing today employs a concept called GET parameters, and this is the normal parameter that you're actually GET requests are what you normally use when you're accessing the web. Just as POST requests can be used to send information to the server, so too can GET requests be used. However, there's one important difference. With POST requests, the data being sent is included in the body of the request, so it's actually it's down below in the actual for section of the request. With GET requests, the data is included in the URL as a parameter. This is best demonstrated with an example. So here we can see we have HTTPS, thebestfestivalcompany.co.uk, index.php, snack equals mince pie. Please note this site is completely fictitious. It does not exist. And even if it were to start existing, it's not part of this task. You don't need to connect to it. Don't waste your time with it. There are 7 different parts which make up this URL. Let's look at each of them in turn. So number 1 here. First up, we have the protocol HTTPS. This specifies whether the request should be made using HTTP or HTTPS. In our example, we're using HTTPS, which is the secure. That's just what the S stands for, and it means that rather than being in clear text, our requests to the web are encrypted, which is what we want, and that's what you should be using. And you can see that, generally speaking, most websites that you're browsing on the web will have that encryption, or at least they should. Next, we have the subdomain, so www. This is traditionally www for World Wide Web to signify that the target is a website. However, this is not essential. Indeed, subdomains can be basically anything you want. For example, a lot of websites use things like assets or API to indicate different subdomains with different uses. So for example, API and then thebestfestivalcompany.co.uk. The next part of the URL is the domain, so the Best Festival Company. Domains need to be registered and are used as links between memorable words or phrases and an IP address because it's a lot easier to remember a phrase than just a bunch of numbers. In other words, they're used to give a name to the server running a website. So, for example, TryHackMe, or in this case, the Best Festival Company. Next up, we have the TLD, the top level domain, which is .co.uk for our example. Top-level domains are used by DNS to determine where to look if they want to find your domain. Previously, top-level domains had specific uses, and many still do. So for example, .gov is used primarily by governments, and you can see a bunch of regional top-level domains as well. But this is not always the case these days. For example, .co.uk indicates a company based in the UK, and .com indicates a company based in the US. However, that's not very true because .com has kind of taken over. We then have the resource we're selecting. In this case, that's the homepage of the website, index.php. As a side note, all homepages must be called index in order to be correctly served by the web server without having to be specified fully. This is how you can go to tryhackme.com without having to specify that you want to receive the homepage. The index page is served automatically because you didn't specify. The final two aspects of the URL are the most important for our current topic. They both relate to get parameters. First up, we have the question mark snack equals. Here, the question mark is used to specify that the get parameter is forthcoming. We then have the parameter name, which is snack. This is used to identify the parameter to the server. We then have an equals sign, indicating that the value will come next. Finally, we have the value of the get parameter, which is mince pie, because who doesn't like mince pies, right? As a quick note, as an American, I have never had one of those. I don't know what that is. I mean, I assume it's probably good because it's in this example. It's important to note exactly which part of the URL is the get parameter. Specifically, we're talking about the equals or the question mark snack equals mince pie. If there was more than one parameter, we would separate them with an ampersand, which is just the and sign. On a typical keyboard, that's going to be on your 7 key. For example, we'd have question mark snack equals mince pie and drink equals hot chocolate. In this way, we can send multiple values to the server, distinguished by keys. This is pretty common to see for search forms. So if you're searching through a website, it's pretty common to see this in the URL. Next time that you are doing a search on a website, try taking a look at the URL and just seeing what's in there. File uploads. There are countless uses for file uploads in the modern internet. Profile pictures, school/university submissions, diagrams, pictures of your dog, you name it. Whilst file uploads are very common, they're also very easy to implement in a secure fashion. For this reason, it's important that we understand the gravity of the attack vector, and older languages like PHP don't do a lot for you in that case. They don't help you a lot. Newer frameworks like Node, they'll guide you a little bit better to make it harder to mess this up, but it's something that I recommend, especially if you're doing some web design. It's worth spending some time on this topic. When you have the ability to upload files to a server, you have a path straight to RCE, remote command injection. An upload form with no restrictions would mean that you could upload a script that, when executed, connects back to your attacking machine and gives you the ability to run any command you want. It would be very unusual to find a file upload with no filtering, but it's much less uncommon to find a file upload that employs flawed filtering techniques which can be circumvented to upload a malicious script. The script has to be written in a language which the server can execute. PHP is usually a good choice for this, as most websites are still written with a PHP backend, very, very common to see. There isn't time to go over every kind of filter bypass in this task, and there's literally an entire room on this topic. This is, I think, a sub-only room, but it's definitely one that if you have a subscription to the site, it's worth going through. It's very, very well detailed and also created by Meerland, which is recommended for further practice. Instead, we'll just cover one of the most common types of filter and its bypass. So this is file extension filtering. As the name suggests, extension filtering checks the file extension of uploaded files. This is often done by specifying a list of allowed extensions, then checking the uploaded file against the list. If the extension is not in the allow list, the upload is rejected. So what's the bypass? Well, the answer is that it depends entirely on how the filter is implemented. Many extension filters split a file name at the dot and check what comes after it against the list, so just immediately after it. This makes it very easy to bypass by uploading a double-barreled extension. So you can see .jpeg.php as an example here, where we have our first dot here, which is where the split would actually be at. So the filter splits at the dots, then checks what it thinks is the extension against the list. If JPEG is an allowed extension, then the upload will succeed and our malicious PHP script will be uploaded to the server. And the server still recognizes this as PHP because the last extension is PHP in that case. When implementing an upload system, it's good practice to upload the files to a directory that can't be accessed remotely. Unfortunately, this is often not the case, and scripts are uploaded to the subdirectory on the web server, often something like uploads, images, resources, or so on and so forth. For example, we might be able to find our uploaded script at the bestfestivalcompany.co.uk/images/shell.jpg.php. Reverse shells. Let's assume that we found somewhere to upload our malicious script, and we bypassed the filter. What then? Well, there are a few paths that we can take, the most common of which is uploading a reverse shell. This is a script that creates a networking connection from the server to our attacking machine. The majority of web servers are written with a PHP backend, which means we need a PHP reverse shell script. And there happens to be one already on the Kali/attack box at this path. So USR share web shells PHP and then at PHP reverse shell.php. Note if you're not using Kali or the provided attack box, you can find the same script here. And that's just a link, I believe, to the GitHub page for that. Copy the web shell out into your current directory. So let's go ahead. We'll pull up the terminal. And as you can see, this is just a tmux session. There's another room on tmux that I can link in the video description if I remember at this point. I'm just connected to the VPN, and this is just a little bit faster so we can actually view the fun animations on the web page. Otherwise, it kind of crawls. So we've got this pulled up. And as you can see, I'm in my Advent of Cyber 2 room, and I've already got my shell here, but we're going to go ahead and copy another one to this directory. USR share web shells, PHP, PHP reverse shell, and there's a couple PHP shells in here, and we'll copy it to this directory /shell. We'll go with jpeg.php. And we'll see if that works. Let's see. Copy the web shell out into your current directory. So we've gone ahead and done that. In this case, you can just do a dot. That just means that it copies to the current directory. I've renamed it. That's all I did there. And you can name it whatever you want. The important part here is the extension. I just name it shell because it's a little bit easier to work with and it's a little bit shorter. Then open it with your text editor of choice. In this case, I'm going to go ahead and open that with Nano. And we'll open that now. It gives us some fun colors. Scroll down to where it has the $IP and $port. And we'll scroll down just a little bit. It should be the first items here. In this case, I'm going to change the IP, but not the port. And you can see that they're clearly marked with change this. This is the only thing that we have to do. If you want to make this a little bit smaller, you can get rid of the comment up here. But for this example, it's not necessary. It's just good to know how to work with this. Set the IP to your TryHackMe IP address, which can be found in the green bubble at the top of the nav bar. If you're using the attack box, that's going to be up here in this area, I believe. In my case, I have a tmux script, so you can see my IP right here. And let's go ahead and change that. And we'll do 10.8.4.3, and then I'm going to leave the port as 1234. A lot of times I'll change the port to 53 just because DNS port is usually allowed out on the firewall, but 1234 works in this example, and I think 53 has some issues on the attack box if I remember correctly. So I'm going to do Control X and then hit Y, and I'm going to press enter to save it as this name, and we should be off to the races. So there we go. You can also get your IP by running this command IP space A show and then ton0, which again is just that ton0 IP if you're using your own Linux VM with the OpenVPN connection pack. Set the port to 43 or 443. In this case, you can do that if you want. I'm doing 1234 just because it's a little bit easier. And then save and exit the file. Congratulations, if you have now a fully configured PHP reverse shell script. And we can see just an example of that file with the edits. PHP reverse shells can be very easily activated when stored in an accessible location. Simply navigate to the file in your browser to execute the script and send the reverse shell. So you can see that we've uploaded it here from our attacker machine to the target, and then we navigate to that file path, and then that runs the PHP code on the server, and it sends the reverse shell back to us. In the diagram, we first upload our shell, then we navigate to the browser, or to that shell in the browser, causing the server to send the reverse shell back to our waiting listener. For a more in-depth explanation of reverse shells, check out the Intro to Shells room. Reverse shell listeners. We've spoken at length about reverse shell listeners, but what are they? In short, a reverse shell listener is used to open a network socket to receive a raw connection. Think of it as for Americans here, baseball, it's like your catcher, because you have to actually catch the reverse shell that's coming back to you. That's the easiest way to think of it in my mind. Like the one created by a reverse shell being executed. So we're just catching that connection. That's all we want to do, because that connection still can be sent back, but if we don't catch it, it won't actually do anything. It's just going to be sent out into the void, and well, that's not very useful to us. The simplest form of a listener is created by using a program called Netcat, which is installed both on Kali and AttackBox by default. And I think you can install this on Ubuntu if you're using that as well, just with apt. I believe it should be in the repositories if it's not installed by default. We can create a listener for an uploaded reverse shell by using the command netcat, so nc-lvnp443. And in this case, I'm going to hop over to my third tab here and run that, but I'm going to use 1234. This essentially creates a listener on port 443, which again is another good one because that's usually allowed out on a firewall, because that's what HTTPS web servers listen on. And the full explanation can be found in the Intro to Shells room linked above if you're interested. Our reverse shell will be able to connect back to this when activated. So putting it all together, that was a lot of information. So let's put it all together and take a look at the full process for exploiting a file upload vulnerability. Find a file upload point, so we need to find an upload form. Try uploading some innocent files and figure out what it accepts, so images, text files, PDFs, etc. Find the directory that those are actually stored in. Try to bypass any filters and upload a reverse shell, and then start a netcat listener to receive the shell. Navigate to the shell in your browser and receive a connection. At the bottom of the dossier is a sticky note containing the following message. For Elf McEager, you have been assigned an ID number for your audit of the system. And we're going to go and copy that. Use this to gain access to the upload section of the site. Good luck. You note down the ID number and navigate to the displayed IP address in your browser. So that's going to be the IP here. And we're going to go ahead and flip over to this. And you can see that I've gone ahead and got the website up. Right away, it's telling us that we need to add our get parameter. So we can do question mark and then ID equals, and we'll paste that in. And I'm actually going to copy this because we need this for our first question. But if we press enter, hold on, I have a space there and we don't need that. So we'll copy that and press enter, and there we go. So first question here, what string of text needs to be added to the URL to get access to the upload page? We'll paste that in, and there we go. So what type of file is accepted by the site? What we can go ahead and do now is we will view the page source, and a lot of times it will actually tell you what is allowed to be accepted by the site in the source code. And in this case, we can see that we have just that. So we have our file upload input form here, and accepts .jpeg, .jpg, and .png files, which pretty easy. That should be fairly simple to bypass. So we can put .jpeg rather, and there we go, image. For the second one, bypass the filter and upload a reverse shell. In which directory are the upload files stored? In this case, you could use a tool like Dirbuster or GoBuster to find the upload directory. In this specific case, I actually recommend, and I'm going to remove this, going to the part in the task, and there are a number of common directories, and we're actually just going to manually go through these and guess. Just because a lot of times you can usually guess this bit. So if we go, and we'll remove that get parameter because we probably don't need it for the upload. And if we go to uploads, we can see that sure enough, we have the upload directory where we can see that I have some other shells that I've thrown up here, and don't worry about those quite yet. We don't need to worry about those. So we found it just by guessing. And a lot of times, like I said, you can just manually guess that. And let's see if that works. So /uploads. And now we need to go ahead and, since we found our upload form, we can go ahead and try to upload that shell that we had created. In this specific case, I've gone ahead and already done that. So if we go back here and go to all supported types, and you can see that I've got these shells here. I've gone ahead and uploaded my .jpg.php file. However, we'll go ahead and try with this one, and it should be happy about it. And there we go. We can see file received successfully. Now, if we go back to the uploads directory and refresh, we should have a new file waiting for us, which sure enough we do. Let's go ahead and pull up our terminal, and I just wanted to confirm we have our netcat listener waiting for us, so we can go back to the website maybe. And if we click on this and go back to here, go back to our terminal, we should see that we now have a reverse shell waiting for us. So we can mark this as complete because we've activated and caught our reverse shell in our netcat listener. And now we have to do is read the flag. So if I go ahead and run the command cat var www flag.txt, we can get the contents of the flag. And we've got a little bit of a message here from the task author. You've reached the end of Advent of Cyber Day 2. Hopefully you're enjoying yourself so far and are learning lots. This is all from me, so I'm going to take the chance to thank the awesome Vargnar. That is Varg. He's in the Discord and pretty active on Twitter as well, for his invaluable design lessons, without which the theming of the past two websites simply would not be the same. And those were pretty fun. Those were very, very well designed websites, as we can see. And we'll hop back over here. Here, have a flag, you deserve it. We'll go ahead and copy that out and paste that in. Good luck on your mission, and maybe I'll see y'all again on Christmas Eve. A little bit foreboding there, but we'll see what happens on Christmas Eve. And that is going to do it for day 2. If you have any questions, feel free to hop in the TryHackMe Discord. I'll have that linked in the video description as well. Otherwise, I will see you guys next day, tomorrow rather, on day 3.